Let's continue with our design lecture series on design of steel structure building as per Indian code. In our previous lecture, we dealt with some defined menu options and we defined various things such as section properties. And in that section properties, we defined beam sections, column sections, we created some auto select properties, and we also defined deck section. So today in this lecture, we will continue with modeling of beams and column and other frame elements in our structure. And before starting with modeling, we are left to define load pattern, load combination, and mass source. So we will first go to the definition of load patterns before beginning with the actual modeling of structure. So let's go to define menu and then go to load patterns here. Dead and live load patterns have already been defined. Now I will add some other load patterns. For example, floor finish. I will select the type as superimpose dead load and then left click on add new load. After floor finish, we can add some wall load. Type again will be super dead, add new load. Then I will add load pattern for earthquake load in X direction, EQX. The type will be seismic and the self-weight multiplier will be 0 and the auto lateral load pattern will be IS 1893-2016. Similarly, I will add for earthquake force in Y direction and then add new load. After that, I would like to add a load pattern named truss. This will also be super dead load, and I would like to add another load pattern for dead load of staircase. This will again be superimposed dead load. Similarly, we can add for live load of staircase, stair live. The type will be live, add new load. Similarly, since we have truss at the top of our building, we will add load for CGI seat. This will again be super dead load. And since this is a steel structure and wind load is an important load, we will add a wind load pattern also. And the type for this wind load pattern will be wind air. And for now, I will not select any auto lateral load. I will just calculate the wind load based on the IS code for calculation of wind load. And then I will apply that wind load directly to our structure under this load pattern named wind. So I won't select any auto lateral load pattern here. And then add new load. And similarly, finally, for live load acting on our roof, I will define a load pattern as roof live. This will be live load and then add new load. So while modeling the structure, if some name of other load comes to our mind and we need to apply those loads to our structure, we will define those load patterns at that time. Let's click on OK. After defining load pattern, let's define load combination. So go to define menu and then left click on load combinations. Since at the very beginning of our model we have already selected our design code as the Indian code, we can add default design combinations based on Indian code. For that, I will left click on add default design combos here, select steel frame design and also select this convert to user combinations editable and then left click on OK. So now 22 load combinations have been added. If you want to see the details of any load combination, just select that load combination and then left click on modify show combo. Then you will be given the load combinations and all the loads and their corresponding scale factors that is defined under that load combination. So I'll just escape from this tab, left click on OK and then left click on OK. Now save the model. Now we will start with modeling of our structure, and in today's lecture we will only model the frame elements including beam, column, secondary beams, deck, slab, truss, and then we will see modeling of staircase in another lecture. So for now, this one story option is active at the bottom. What we will do is we will just design or we will model our structure for the ground floor, and for the remaining 2 floors we will just copy that elements that we have modeled at the ground floor and then replicate those two to the 2 stories above. So for that, first let's add a new window here. You can do that by going to this window list and then add new window. I will activate this view on the left hand side and then show a plan view here at story 1. This reference plane, just forget about this reference plane for now. We will talk about this reference plane when we model staircase in our next lecture. We will go to story 1. Now we will start with modeling of columns. For that, you can either go to this draw option, draw beam column brace object, and then this quick draw column option, or you can directly press the shortcut key or shortcut icon that is available here, quick draw columns. So before drawing this column, let me go to my define menu, section properties and frame section. We used the section designer to define a 2 ISMC 300 section for column. So select this and then left click on modify show property and then go to this section designer. Okay, I will just delete this for now. We defined this ISMC 300 channel and found a 300 mm by 225 mm column section in our previous lecture, but we did not add batten plates in this section designer. So what I would like to do is I would also like to draw batten plates here, and I will draw that batten plate using 80 mm thick steel plate. So for that, go to draw menu and go to steel and then select this plate option. Now you can see here it says left click wants to draw plate, center of object is at click location. So I will use this as center and then left click here. So this is a very big batten plate. To modify its dimensions, just select this using your left hand mouse button and then right click on it. So this shape name, let me leave this as plate 3, material Fe250. Now the geometry is, the width will be, since this dimension parallel to x-axis is 225 mm for our column, I will use the same width here, 225 mm, and thickness I will use 8 mm batten plates for now. We will see the design of this composite or built up section column in our design lectures also. For now I'm going to use 8 mm thick batten plate and then left click on OK. So one batten plate has been drawn on one side. Now I would like to replicate it to the other side. For that, just select this batten plate that we have just drawn, then go to edit and replicate option. We can mirror this element about this x-axis so that this batten plate is drawn to the other side also. So go to this mirror option and select x-axis. It is already selected and then left click on OK. Now the batten plates has been drawn on both sides and then our built up section is complete. So now left click on OK, again left click on OK, and again left click on OK. Now we will go to drawing column. So this draw column option is already selected. Select the property as ISMC to ISMC 300. Now after selecting the property, just select all of these grids here in this way. Make this rectangular selection. Then these columns will be drawn along all the intersection of these grid elements. Remember that we have selected this one story option here at the right hand bottom corner. So only these column elements will only be drawn on our ground floor. Now let's see here, let's press the escape key at first, or you can also click on this select object option. You can see that since ours is a rectangular column here, and this longer side of our column, which is parallel to this horizontal direction here, this longer side of our column is directed along the x-axis. But since the length of our building is along this x-axis, and there are enough column elements and grids along this axis, our structure is already stiffer in the x direction. So what I would like to do is I would like to rotate these columns and make this longer side of the column parallel to y-axis so that the stiffer side of the column is along the y direction. For that, I will select all of our column elements, then go to Assign, Frame, and Local Axis. If we rotate these columns by 90 degree, then this longer side will be in the y direction. So in this general orientation, in angle option, just write 90 and then click on OK. Now our columns are oriented, that is the longer side of our columns are oriented along the y direction. So column modeling is complete. Now let's go to drawing our beams here. So for that, select this quick draw beam column option and select our beam as auto beam. If you remember, in our previous lecture we created an auto select list for our beams. We have talked about auto select list in that lecture also. So we will select auto beam here and then draw beam along all of these grids here. So our beams have been drawn along all the grids. Now what I would like to draw is, since the distance between these two grids in the y direction is 5.27 meter and this may be a greater span, so we will like to draw secondary beams that support these primary beams. And to draw the secondary beam, we have created an auto select list again, auto sec beam in our previous lecture. To draw that, what you have to do is you have to go to this draw option, draw beam column brace object, and quick draw secondary beams. This option is also available on your left hand side. Now this property, select it as auto sec beam, and you can see that moment releases are pinned, since we suppose that these secondary beams act only as braces to the primary beams, but they do not transfer any moment, that is their end connections are pinned. So moment releases will be pinned. If it was for primary beams, it would be continuous. For secondary beams, these are pinned. Let's say that we will draw three secondary beams along these two grids, between these two grids, and these beams should always be oriented along this shorter direction, because our primary beam are in the longer direction, and to support them we have to draw them along this shorter direction, that is here parallel to x-axis. So select this parallel to XRT. Now then, if you hover over your model, since we have selected number of beams as 3 secondary beams will appear. Just left click between these two grids and then these secondary beams will be generated. In between this B and C grid we have staircase, so we won't draw secondary beam for now. Do the same for all other grids, between C and D, between D and E, and then between E and F. So this is how you draw secondary beam. For this, our between grids B and C where we have staircase, if you go to our AutoCAD plan, you see that our staircase starts at a distance, or this landing slab on our first floor is at a distance of 1.935 meter. So in this space we will have deck slab resting, and above this, and to support this deck slab we have to draw a secondary beam here at a distance of 1.935. To do that, what I will do is, we will see another way to assign or draw secondary beams. What I will do is just select this beam here and then go to edit and replicate option. So the distance is 1.935 meter, so we will replicate this beam in positive y direction once. So dy will be 1.935 meter and then left click and OK. Now if you select this beam here and then right click, you can see that this is our ISMB 300, that is auto select beam. This is now acting as primary beam, and to convert this to a secondary beam we have to convert this connection here to pin connection. For that, what we have to do is we have to release the moment at the ends. To do that, just select this beam here, go to assign, frame, and release as a partial fixity, and release the torsion at one end and the moment at both ends, that is start and end, and then left click on OK. Now this will also act as secondary beams. Now after completion of this drawing of frame elements in one floor, now we will draw deck slab section. For that you can use these three options. For now I will use this draw rectangular floor wall option, and in that I will select the property we have defined as deck slab, and I would like to draw deck slab here. In this way, just left click on one of these corners, and after this selection that snaps at another corner, just release your mouse button. This is how you draw the deck slab. Now you can see that what these arrows represent is that the loads are being transferred to these, its right hand side and left hand side for all of these deck slab, but we want these loads to be distributed to our secondary beams. That means we have to change the orientation. Again, we have to change the orientation of this deck slab section, similar to what we did for columns. So select these deck slab sections and then go to Assign, Shell, and go to Local Axis. Now again, reverse the local axis orientation by 90° and then left click on OK. Now you can see we have a one-way slab distribution here, one-way load distribution. Now our loads will be transferred first to the secondary beams, and only then the loads are transferred to our primary beams here. So after modeling of these frame elements in one floor, what I would like to do is I would like to replicate all of these elements to the 2 stories above. For that, just click on Ctrl A for selecting all the elements that we have drawn. Then click Ctrl R or go to Edit and Replicate option. We will replicate these to story 2 and story 3. So go to this story option, click on Ctrl on your keyboard, do not leave it, and then select story 2 and story 3 and then left click on OK. Now all of these elements have been replicated to second and third story. You could replicate this after the application of your loads also. For example, you could first draw all the elements in the first floor, apply all the loads, and then replicate it to our second floor and third floor. But for now, we just replicated these elements only. So now we are left with modeling of truss and then modeling of staircase, which we will see in our next lecture. Before ending today's lecture, I would like to apply restraints to our base here. So click this down arrow to go to Z equals to 0 meter. That means at the base, select all of these joints, go to Assign, Joint, Restraints, and select this fixed restraint and then left click on OK. Save your model. If you want to see an extruded view, just I will close this plan view here and then go to this Set Display option. Click on Extrude Frames, Extrude Cells, and then click on OK at the very bottom. Now you can see the extruded view of your building that you have drawn here. If you want to view these elements by different colors according to the different section properties that we have defined, then go to this Set Display option again, go to and select this View by Colors of Section Properties, and then click on OK at the bottom. Now you can see your elements according to the section properties that we have defined here. So save your model, and we will continue with modeling of our truss and staircase in our next chapter or in our next video lecture. So see you again very soon perhaps. Okay, before ending, what I would like to do here is let's not extrude view and then go to objects. So let's go to our this third floor level. for that, plan and then story 3. Now above this floor we have truss here, so we do not need this deck, and also we do not need this secondary beams here since this does not act as a supporting floor. So select this deck slab in our topmost section and then delete them. Also you can select these secondary beams and then delete all these secondary beams. Delete. Now if you go to 3D view, there is no any floor at this level because we just have truss exactly above this floor. So save your model, and we will continue with our modeling lecture in next class, and if needed after that class also. So see you there.